Hello everyone, this is Steve. Thanks for joining me for another video. This is a video where we're going to solve for x in equations where we can make the bases match. None of them match as we start, but we're going to make them all match so we can get a proper value for x. So looking at this first one over here, I can see that I have a 3 stuck down here and an 81 right here. Now, my common base is going to be 3 on this one. So on the left-hand side, I want to rewrite 81 as 3 to a power. 81 can be rewritten as 3 to the 4th. So this left-hand side I'm going to rewrite as 3 to the 4th to the x minus 3 power. Oops. Okay. On the right-hand side, I need to make it so this is just a base of 3 also. So we have a square root of 3 in the denominator. Now, if we have a square root of 3 in general, that's the same thing as 3 to the 1/2 power. But since it's in the denominator also, it's actually going to be a 3 to the negative 1/2 power. So I can rewrite this as 3 to the negative 1/2, and then 4x out there. As I said, the negative is because it's in the denominator, the 1/2 is because it's a square root. Now we clean up these parentheses by doing some distributing. So this 4 will distribute to both of these, and then this negative 1/2 will just multiply by this 4x right here. This is going to give me 4x minus 12 equals 3 to the negative 2x. Now that the bases match exactly, I can just set the two exponents equal to each other. 4x minus 12 equals negative 2x. I'm going to add 2x to both sides. Add 12 to both sides. Divide by 6, and I get x equals 2. And that's done. That problem is done. Okay, let's look at this next one with the e's in it. Sometimes e's freak people out. There's actually nothing to do on the left-hand side. It's all set to go. E to the x plus 1. On the right-hand side, since we have an e squared in the denominator, that e squared can come up to the numerator as long as we rewrite it as e to the negative 2 instead. So we just rewrite 1 over e squared as e to the negative 2 power. Then, left side is still fine. Don't need to change that at all yet. But on the right side, we distribute this negative 2. And when you distribute that, not only you distribute the 2, you distribute the negative sign. So check this out. You're going to get e to the negative 10 plus 2x, which just for the purposes of solving this problem, I think it's easier to think of that as e to the 2x minus 10. Although that's not necessary to do that last step I just did. Now the bases both match as e, so we set the two exponents equal to each other. I'm going to go ahead and subtract 2x from both sides. It's going to give me negative x plus 1 equals negative 10. I'm going to go ahead and subtract 1 from both sides, giving me negative x equals negative 11. But since it's negative x equals negative 11, you either divide or multiply both sides by negative 1, then you get x equals 11. And that one's done. You can see it really didn't matter if we knew the value of e, just as long as we got the bases to match. All right, this last one here where we're going to solve for x, the problem is we cannot rewrite the larger base 32 as 16 to a nice clean power. So it's going to be easier to break them both down to a common base. And the common base that you can break them down to most easily, is a base of 2. So 32 can be rewritten as 2 to the 5th. And 16 can be rewritten as 2 to the 4th. And that's probably the hardest part of that problem, is seeing that you need to rewrite the 32 as 2 to the 5th, and the 16 as 2 to the 4th. Because once you do that, you just go ahead and fix your powers here with a little bit of multiplication, distributing on the right-hand side there, and we will get 2 to the 10x equals 2 to the 4x minus 4. The bases match. 10x equals 4x minus 4. Go ahead and subtract 4x from both sides. You get 6x equals negative 4. Divide both sides by 6. Get negative 4/6. That's actually the correct answer, but you can reduce that fraction down to negative 2/3. So in all three of these problems, we could make the bases match. We just need to do a little manipulating, and then once the bases matched exactly, we set the exponents equal to each other and solve for x. Thanks for watching. I hope that helped.